Welcome to solverfy.
So we have three sheets of three different charge densities, sigma 1, sigma 2, and sigma 3. Notice that sigma 2 is negative, whereas sigma 1 and sigma 3 are positive. So we want to find out the force per unit area, which is basically pressure for each sheet. So now we know that force is Q times, where Q is the charge and E is the electric field. Hence, force by area is Q by A times E, which is sigma times E, because Q by A is simply charge density. Hence, F by A for a particular sheet, let's say the first one, will be the charge density of that particular sheet times the electric field due to the other sheets. Now also remember that the field due to the first one, so let's count the fields on the first one. The field due to the sigma 2 will be downwards, whereas let's call this F2, the field due to second sheet, and the field due to the third sheet will be upwards because it's positive. So let's find out the values. Also remember that the electric field due to a charge sheet is sigma by 2 epsilon naught. Now that we have this information for part A, to find F by A for sheet 1, it is equal to, as we saw, sigma 1 times E2 plus E3. So that is sigma 1 times, we know that E2, E3 are sigma by 2 epsilon naught. So that's sigma 2 plus sigma 3 by 2 epsilon naught. But notice that sigma 2 and E2 and E3 will have opposite directions, and so do sigma 2 and sigma 3. So it's fine. Now this is equal to, we know that sigma 1 is minus 2 into 10 power minus 9 coulomb per meter square, divided by 2 times epsilon naught is obviously 8.85 into 10 power minus 12 times, we know that sigma 2 plus sigma 3 is 5 minus 2 into 10 power minus 9 coulomb per meter square. Let's write down the values beforehand here. This one is 6.5 Newton nanocoulomb per meter square. The second one is minus 2 nanocoulomb per meter square. The third one is 5 nanocoulomb per meter square. Now, by plugging these numbers into a calculator, you can see that this is equal to 1.1 into 10 power minus 6 Newton per meter square. Now, for the second sheet, the force due to the sigma 1 will be downwards, whereas the force due to the sigma 3 will be upwards. So we want to find the difference between F1 and F3. Now, F by A for 2 is equal to sigma 2 times sigma 3 minus sigma 1. I'm sorry, E3 minus E1, which will be equal to sigma 2 by 2 epsilon naught times sigma 3 minus sigma 1. Now this will be equal to minus 2 into 10 power minus 9 divided by 2 into epsilon naught is 8.85 into 10 power minus 12. We know that sigma 3 is 5 Newton nanocoulomb per meter square and sigma 1 is 6.5 nanocoulomb per meter square. So that's 5 minus 6.5 into 10 power minus 9 coulomb per meter square, which gives us 1.7 into 10 power minus 7 Newton per meter square. Notice that this will be in the upward direction, which is why we chose sigma 3 minus sigma 1 instead of sigma 1 minus sigma 3. Because the field due to sigma 3 would be upwards. Hence, when we do F3 minus F1, our resultant field will be upwards, depending on the sign, of course. If it's positive, it's upwards. Now, for part 3, F by A for the third one will be simply sigma 3 times. If you notice, the field due to the first one will be downwards, whereas the field due to the second one will be upwards, F2 and F1. So we can simply do F2 minus F1 and find the force in the upward direction. So that's E2 minus E1, which will be sigma 3 by 2 epsilon naught into sigma 2 minus sigma 1. Notice that sigma 2 is negative and sigma 1 is positive, so I put mod signs here so that this minus sign will stay as a minus sign. So this is equal to sigma 3, as we know, is 5 into 10 power minus 9 coulomb per meter square divided by 2 into, we know that epsilon naught is 8.85 into 10 power minus 12 coulomb square per Newton meter square. And we know that sigma 2 minus sigma 1 is 2 minus 6.5 into 10 power minus 19, minus 9 coulomb per meter square, which gives us minus 1.3 into 10 power minus 6 Newton per meter square. Now you see that because this number is negative, it means the force will be downwards. So one more thing to note is because this number is positive, the field on the first sheet will be upwards too. That's it.